Bismillahirrahmanirrahim. Dear students, I am Muhammad Waheed Iqbal. Today I am with you with BSc Associate Degree Part 2. Here is differential equation. What is differential equation? The definition: an equation involving derivative with one dependent and one or more independent variables is called differential equation. An equation involving derivative in which dependent variable will be one and independent variable will be more than one. It depends upon whether the differential equation is ODE or PDE, ordinary differential equation or partial differential equation. The example is du by dx plus du by dy. Here u is dependent variable, x is independent, another y is independent variable, plus u is equal to 0, and this is partial differential equation. Again, d square u over dx square, u is dependent, du by dx, u is dependent, x is independent, here x is independent, so only one independent variable, and it is ODE, ordinary differential equation. So these are the example of differential equation. Basically, a differential equation is that in which the derivative is involved. Second is order of differential equation. The highest order derivative involved in the differential equation denotes its order. The highest order derivative, what will be the order of derivative? Here is second derivative involved, that is first order. The highest order derivative involved in the differential equation that denotes its order. So the order of this differential equation is 2 because here is the second order derivative involved, and that is the highest. The second example is du by dx plus du by dy plus u is equal to 0. Here is u is dependent and x is independent. And there are two independent variable x and y, so it is partial differential equation, and the order of the derivative is the highest order of derivative. Here is 1, first order derivative involved, and here is also first order derivative involved, so the order of this differential equation is 1 due to the order of derivative. The second, and now the degree of differential equation, the radical free exponent of highest order derivative involved in the differential equation. The radical free exponent mean the exponent should be from the whole number, it should not be in fraction, and it should not be in a negative sign. Radical free, radical mean the sign of square root, cube root, that is a radical designate. Here is the exponent is 3, exponent is 4. Radical free exponent, the exponent should be from the whole number, not it should be in the form of square root, cube root, or anything else, such as the radical free exponent of highest order derivative. Highest order derivative whose exponent should be radical free, that will be the degree of differential equation. Here is the highest order, second order. The exponent of that second order derivative here is 3, here is 4, but it is first order. We have to observe that the exponent of highest order derivative, that will be the degree of differential equation. Here is second order derivative and its exponent is 3, so the degree of this differential equation is 3, because the definition is radical free exponent of highest order derivative. Radical free mean I have explained that it should not be n square root, cube root, or any root form. The order of this differential equation is 2 because second order derivative is involved, and the degree of this differential equation is 3 because the exponent, because the power of the highest order derivative here is 3, so the degree is 3 of this differential equation. Now there are some example. 1 plus dy by dx whole raised power 3 by 2 is equal to d square y by dx square. Here what will the order and degree? Here is a radical involved, 3 by 2. So squaring on both sides, we have to take square on both sides. Squaring on both sides, it will become 3, 2 will be cancelled, and here will be an exponent. Here will be exponent will be 2 due to the square factor. The exponent will be 2 of second order derivative, so the order of this differential equation will be 2, and due to squaring on both sides, the exponent of this highest order derivative again will be 2, so the order of this differential equation is 2, and degree of this differential equation is also 2 due to square factor. Second example, partial square u over partial x square plus partial square u over partial y square plus partial square u over partial z square. That is a partial differential equation because dependent variable is u in all cases and independent variables are x, y, and z. Here is the second order derivative involved in each case, so the order is 2 and the degree is 1 because the exponent of each second order derivative is 1. So order is 2 and degree is 1. Here is 8 cos square y dx plus cosecant square x dy. And here first we have to arrange it in the form dy by dx. By moving this part towards right, it will become negative. Then dividing by dx, we have dy by dx is equal to something in trigonometric function. So the order of this differential equation will be 1 because we have dy by dx only single order derivative. The order will be 1 and the degree is again 1 because the exponent of dy by dx will be 1 when we by shifting this term towards right and separating dy by dx, the order will be 1 and the exponent of that first order derivative will be 1. So the degree of the differential equation is also 1. Number 4, dq minus 27 into y is equal to 0. That is a highest order derivative. We can write this differential equation as dq y over dx square. The order of this differential equation is 3 because third order derivative is involved. Dq y over dx cube minus 27y is equal to 0. And the degree, that will be the exponent of highest order derivative. Here is the exponent, mean power is only 1. So the degree of this differential equation will be 1. And the order is 3 due to the third order derivative involved in this differential equation. Gentlemen, that was the definition of differential equations, order of differential equations, degree of differential equations, and with some examples about order and degree. There will be many more definitions, so you all are to be in touch the definitions of other types of differential equation like linear differential equation, non-linear differential equation, homogeneous and non-homogeneous differential equation, exact differential equation, orthogonal trajectory, and differential equation solved for p, x, and Clairaut differential equation, and many more like different types of differential equations regarding mathematical methods, chapter number 9 and chapter number 10. With the passage of time, you should also be in touch in order to learn all these definitions.